Hey there, and welcome. Have you ever really stopped to think about what happens when you type a website into your browser and hit enter? It feels instant, almost like magic. But behind that screen, there's this incredible hidden map, a massive address system that guides every single click you make. Today, we're going to pull back the curtain and explore that map. So let's follow the journey of a single click.
Think about it. You do this dozens, maybe hundreds of times a day without a second thought. But that one simple action kicks off an amazing journey for a tiny packet of your data. So where does it go first? Well, let's trace that signal, and you might be surprised to learn that it all starts right inside your own home. Okay, so before your request can even think about zipping across the globe, it first needs an address inside your own little network. You can think of it like getting its local paperwork sorted out before it goes on a big trip. It all begins right here with your digital house number.
So here's where it gets really interesting. You don't just have one digital identity, you actually have two. See, your device, your laptop, your phone, whatever, it gets a private IP address. This is like the number on your apartment door. Only the other devices in your home need to know it. But then your entire home network shares one single public IP. That's like the main street address for your whole apartment building. It's the only address the rest of the internet ever sees.
Now, to keep things from getting chaotic, the internet basically reserved a few special blocks of numbers just for these private internal networks. And yeah, you've probably seen that top one before, 192.168, something, right? Anytime you've tried to mess with your router settings. These addresses are meant to be invisible to the outside world, which means my 192.168.1.5 can exist at the same time as yours, and there's no conflict.
So who's in charge of handing out all these private house numbers? Well, that's the job of a little thing called DHCP, the address manager that's built right into your router. When your phone joins the Wi-Fi, it basically says, "Hey, I'm here," and DHCP just hands it a unique address from its list. And the best part? It's all automatic. It's the reason you don't have to manually configure every single new device you bring home. It just works.
All right, so our little packet of data has its local address. It's ready to go. Now it needs to actually leave the house and get out onto the massive public internet. This is the moment it gets its passport stamped, getting ready for the journey from your cozy private network to the public superhighway.
You can think of your whole home network as what's called a subnet. The easiest way to picture it, it's like a single quiet cul-de-sac on the giant map of the internet. This setup is super efficient because it keeps all your local traffic, like, say, streaming a movie from your computer to your TV, contained. It doesn't have to go all the way out to the main internet just to come right back again.
Okay, so here's the million-dollar question. How does a device with a private inside-only address actually talk to the outside world? This is where your router plays the hero, using a clever trick called Network Address Translation, or NAT. Basically, your router acts as a doorman. It takes the request from your laptop's private IP, swaps it out for your home's public IP, and sends it on its way. Then, when the reply comes back, the router remembers who asked for it and sends it directly to your laptop. It's the ultimate gatekeeper for your network.
So these addresses we've been talking about, the ones that look like this, they have a name, IPv4. It's the classic format. Just 4 numbers, each one between 0 and 255, all separated by dots. Each of those numbers represents 8 bits of data, so it's a 32-bit address altogether.
And that, right there, leads us to a huge problem. When the internet was first designed, 4.3 billion addresses seemed like a nearly infinite number. Who could possibly use that many? Well, we did. With phones, watches, smart fridges, and everything else coming online, we started running out of room. Fast. The internet was literally facing an address crisis.
So what was the solution? Well, say hello to IPv6. Just look at this thing. It's a monster, right? This is a 128-bit address, which is, it's just mind-bogglingly bigger than IP4. You don't even need to understand the math. The visual difference alone tells you the whole story. This new system was built to make sure we would never, ever run out of internet addresses again.
To really put that number into perspective, this quote says it all. The number of possible IPv6 addresses is so astronomical that you could assign a totally unique one to every single grain of sand on the entire planet and still have leftovers. Yeah, so safe to say, problem solved.
All right, so our request has left the house with a valid public address, and it's out on the open internet. But it still needs directions. See, it knows what it's looking for, YouTube.com, for example, but it doesn't know where that is. Computers don't speak in names, they speak in numbers.
And that's where DNS saves the day, the domain name system. The easiest way to think of it is as the internet's giant shared phone book. Your computer doesn't understand YouTube.com, but it knows how to connect to a specific string of numbers. DNS does that one simple, absolutely critical job. It looks up the name you typed and hands your computer back the correct IP address. Seriously, if DNS ever stops working, the whole internet feels broken to us.
Okay, we followed that single click all the way from your laptop, out the door, and to its final destination. So now let's bring it all back home and talk about why any of this actually matters to you. Why is this stuff so useful to know?
I mean, why should you care about all this, right? Well, because knowing this is like getting a backstage pass to your own digital life. Suddenly, you can figure out why your Wi-Fi is acting up, you can peek at your router's device list and spot an unrecognized device that might be a neighbor, borrowing your connection. And you finally understand, on a deep level, how privacy tools like VPNs and firewalls actually work their magic.
Okay, now for the really cool part. Let's stop talking about this stuff in the abstract and actually see it in action. You can find both of your digital identities, your private house number, and your public street address in just a few seconds.
Seriously, go ahead and try this out. Just open a command prompt or a terminal on your computer and type in ipconfig if you're on Windows or ifconfig on a Mac or Linux. You'll see that private 192.168 address we talked about. Then, open your web browser and go to a site like whatismyip.com. You'll see a totally different number. You've just met both of your digital selves. Pretty cool, right?
And that really brings us to the big takeaway here. Every single website you visit, every online service you connect to, they all see that public IP address. It is, for all intents and purposes, your digital location, your return address for the entire internet. So the real question I want to leave you with is this: who do you want knowing where you live online?